Hello, everybody. Thank you, everybody, for being here and for joining us here. And today, the topic that will be covered is high performance animations. And this is something that I personally found very exciting when I first learned about doing animations in websites. And I'll be honest, I kind of went nuts at the start and just starting adding animations to everything. And yeah, that was a very big mistake, which I soon learned that animations kind of have a cost. And this cost is what makes them so tricky to use successfully, and that's what this session is going to be all about. And yeah, so let's get started with a brief introduction on animations. So let's first go over why performance matters. So you should be aware that the web pages you write and transitions will often not be challenged only by screen size and resolution, but also by the running device's CPU and GPU capabilities. So that means not everybody has a shiny new iPhone X or a shiny new Google Pixel or Galaxy S10. Most of the world still has low to mid-range devices, and in these kind of devices, sites run pretty poorly. So you have to be very cautious about this animation cost. Otherwise, you can harm the user experience of mobile users. And for those thinking like, mobile users, why should we care? Yeah, that would almost be true, except that mobile users make up 50% of all Google searches that came worldwide in 2018. I'm fairly certain this number is already at 60%. I should have this is old data. I'm pretty certain we're already at 60. And of that, I'm also pretty sure that high-end devices probably don't make even maybe 10-15% of the world market share, because right now the as far as I know, I'm kind of a techie. I love reading news about this, but the biggest mobile markets right now are still developing countries like India or China or Latin America. So yeah, definitely you need to consider that whenever you make any kind of mobile animation or transition. All right, so let's continue. And before we can actually learn about how animations run, why it's important to get them to run smoothly, there's two tiny but important details you need to be familiar with, and that's 60 frames per second and device refresh rates. So for those unfamiliar, most devices today, even low-end devices, refresh the screens at about 60 times a second. This is also sometimes commonly referred as 60 hertz or 60 hertz displays or 60 frames per second. Now, the reason this is important is because browser animations and transitions need to match the device's refresh rate and put one new picture or frame for each screen refresh. So basically, if you don't animate something this 60 times a second that the screen refreshes, then what basically happens is that the content on the screen will judder and jank and basically negatively impact the user experience. I'm sure you've all had the experience of browsing a site where you open maybe the sidebar, the nav bar, the hamburger menu, and it just animates so slowly and like it doesn't kill you, but it feels like very like I don't know, unpolished, or like I wish that was a smoother experience. And the worst thing is, this doesn't even happen just on low-end devices. I mainly own flagship devices and smartphones. I love smartphones. I change, be it a good or bad thing, I change them almost on a every 3-4 month basis. And I'm surprised at the amount of sites that I visit and use on a daily basis that still run like crap, honestly. Like, this site is a major website that gets hundreds of thousands of visits probably a month. I have no idea why they still have such an atrocious user experience. Like, the animations just freeze up like crazy. So it's definitely important. So having covered that, there's something you need to understand before you can actually make cool, fast animations, and that's the browser rendering pipeline. This is quite an advanced topic, I'll be honest with you. This is probably not what you were expecting when you joined the session, but let me tell you, this is super ultra important if you want to make smooth animations, because you need to understand the entire process that happens every single time you generate a frame. So remember how we said you had to render a frame or an animation frame once every 60 seconds, 60 times every second, sorry. Basically, this entire process has to happen in 1/60th of a second. So JavaScript, style calculations, layout calculations, painting calculations, and composite. This is all has to run in 1/60th of a second. So say we have 100 milliseconds and we divide it by 60, you have exactly 16 milliseconds to do all of this. So yeah, that's a very tight budget. Let's be real here. That's a very tight budget. And it's not something that's just going to magically work if we don't put any effort into this. So let's go through this rendering pipeline, and let's understand what causes each of these to become pipeline blockers, okay? So I'm not going to dive into too much detail on this, but just so you know, the Chrome DevTools are just an amazing tool for us web developers just to identify all kinds of issues, including performance issues. And I actually have a workshop for the Chrome DevTools, which if you're interested, feel free to attend on the next schedule for that. But basically, there's a performance tab which you can use. It was previously called the timeline panel, and this is basically a powerful tool to help you analyze performance issues of the page, and it allows the recording and exploring of all events in the site's lifecycle. So for example, if we click that link, let me show you what that looks like. So I just love how the DevTools have such great documentation. So if you want to learn about any of this, you can just visit the official site, and they teach you how all of this works and what you would use it for. So how to record page performance, what it looks like. It gives you in-depth graphs about what's taking up most of the browser around the pipeline. So as you can see here, scripting or JavaScript is a heavy burden here on the page. Then also the next contender is rendering. And last but not least is painting. So it looks like the problem here is it has to be either in JavaScript or the rendering process. And so on and so on and so on. So as you can see, this is pretty cool. And it's something you should be familiar if you want to take this to the next level. So having said that, just know that this is what you can use to identify slow animations or page performance issues with the performance tab. All right. All right, cool. Let's move to the next topic, which is finally, first step, JavaScript. So how can we optimize JavaScript? And basically, before you can think about JavaScript, you have to know that JavaScript is the main reason why it can sometimes be a problem is because JavaScript animations are a thing. For those unfamiliar, we normally did in the past JavaScript animations with something called setInterval or setTimeout. So to show you this, to better illustrate this, I'm just going to show you this live example here. So this is the example. Let's open that super quickly, and let's see this quick and easy JavaScript animation. So it's literally just a square that's going to animate from left to right, as you can see here. That's animating. And notice how it's HTML and CSS, there's nothing to it. It's just literally a box, but the actual magic happens in the JavaScript. So we have an animate function, which all it does to animate it is we have a start and ending position. We have the current position. And then what happens is it increases the current position by 1. Then if the current position is still smaller than the ending position, we do a set timeout in 10 milliseconds. And then every 10 milliseconds, it will adjust the box's CSS property left property to the current position. So first it's going to be 0, then 1, then 2, 3, 4, 5, 6, until it reaches that ending position. And once that's changed, it triggers another time the animate function. So this function calls itself recursively until it finishes the animation loop. And that's basically what's been happening. So you might say, okay, that's cool. setTimeout works. Why don't we keep doing this? Like this works, no problem. You saw that. We can change this. Should have been a 1. Let me see if, there we go, that's a 1. So that animates, as you can see right here. So the reason why we stopped doing that is quite simple. The problem with setTimeout is that setTimeout has no worry or doesn't care about when in the browser rendering pipeline it fires. So for example, let's say your setTimeout fires when the JavaScript phase is about to end. So if setTimeout fires at, say, just before a frame is going to end, then it pushes back their entire pipeline, forcing lost frames. or basically jank. So basically set timeout, never use that. This is why we actively avoided JavaScript animations for a long time. Like there was a lot of years, like JavaScript animations were considered bad because they had atrocious performance. And here's a hidden secret. jQuery has an animation method, which a lot of rookie developers used, that had a terrible fame because that used set timeout for animations. And because so many sites rely on jQuery, that is also a big reason why we still have a lot of atrociously animated sites, because of developers with no understanding of the browser rendering pipeline just used jQuery's animate method, which relied on set timeout, which is atrocious for performance. It works horribly. You never want to use set timeout. And this is why we actively advocated to never use any kind of jQuery animation method. I do think this has changed in the latest jQuery version, but also feel free to do any investigation on your own, just to verify that you're not relying on set timeout if you do decide to use jQuery for animation. So, okay, set timeout is bad. Okay, what do we use then? I'm glad you asked. So we actually would use something called a request animation frame. So request animation frame is a new browser API which guarantees that this JavaScript snippet will run at the start of the frame. So basically, this function that we have here, so we do request animation frame, this function will run always at the very start of the frame. So here, it would start running here, giving you a lot more time so you don't miss the frame. So you always want to be using request animation frame for any kind of JavaScript animation. And to demonstrate that, here I have a very simple example, which you can see the comparison between that and the set timeout approach. So the only thing that happened is it looks the same. You still have the animate function. It runs a lot smoother, as you can see. It doesn't skip any frames. And this time, the only thing that changed was instead of doing set timeout, we do window.requestAnimationFrame. And it iteratively just constantly animate it until the entire loop ends. So yeah, actively avoid set timeout. It's, trust me, for your own good. You want to never use it. Now, there is a bonus chapter here, which is something that I know not many of you are going to be very familiar with, but please bear with me. So I know it's a common practice in the industry to add event handlers, so you know how to listen for events on clicks, or on form submits, or on hovers, or on whatever's. But you can also listen for events when you do on scroll or on resize. And this is often used for those cool parallax effects that I think you've already seen, where you scroll and the background moves in slow motion. That's usually achieved with something like this. And this is considered universally a terrible practice. This is why those sites also tend to run pretty crappily. And yeah, it looks amazing, but it runs like crap. So the reason being is because if you're listening for events on every single scroll, and your JavaScript takes too long to run, basically it's going to block entire frames from completing on time, and also going to be a huge cost for slow frame rate. Now, to avoid this, you could use one of these two semi-advanced techniques called debouncing and throttling. So let me show you an example of that, because I think this is just going to be much easier if you see it in action. So debouncing and throttling literally just limit the amount of times the event can fire in the specific time frame, but they do it in very different ways. So I'm going to scroll to the bottom, and I want you to see this number. How many times it's going to fire an event, because it's listening for the on scroll event, as you can see here. So it's doing on scroll, it's going to increase this number. Let's start. That's how many times JavaScript fired while we scrolled. Now, let's try throttle. See the difference? Basically, it limited how many times it could fire, basically over a time period, allowing us to still listen for events while we scrolled, but it limited the number to basically, let's say, only fire every 100 milliseconds. Or something like that. So if we try to scroll up again, notice how the number increases. This time we scrolled much faster. It added like 60 events. if I scroll much faster here, it added, wow, it added less than 10 events. So throttling is one technique, and debouncing is one of my personal favorites. If you do debouncing, basically if I scroll to the bottom, basically it doesn't fire until it detects you stopped basically constantly firing it in rapid fire. So for example, if I do one long scroll, I'm going to do one long scroll. It fired once, only after it detected I stopped scrolling. If I do one tiny scroll, it fires once again. Again, one large scroll. Basically, it fires just after it detects the event stopped firing on rapid fire. So these two are amazing. So that if you do need to listen for on scrolling events, or basically events that just fire constantly, do make the use of these smart JavaScript techniques to reduce the amount of times your code is running. Okay, cool. Let's move on. So next is TLDR. So big takeaways here. Avoid set timeout or set interval like the plague for animation. Always use request animation frame instead. It has much better performance. Always use throttling and debouncing on long-running input handlers like on scroll or on resize. And last but not least, avoid using the jQuery animate method if possible, because it used set timeout. Take this with a spoonful of salt, because I'm unsure of this at the time of writing this, but I still avoid it just out of sanity reasons, because you never know what version of jQuery you're using. So, okay, let's move to the next section, which is style calculations. Let's see what's next. So, the cost of style changes. So, style changes is something we tend to underestimate. We think like, they're just style changes, let's not worry about that. But they can actually be costly. Like, not always, but when you have complex selector matching, basically the process of figuring out what styles apply to what element, basically that takes also processing power. So complex selectors can cause problems in applications where they apply styles to a large amount of elements. And the easier way to solve this is by, number one, using simpler selectors, or just switching to a CSS methodology like BEM, which relies on faster class selectors. If you don't know what BEM is, feel free to Google this and look it up. Let me tell you this right now, it's not pretty. I hate BEM, but it's industry standard, it's fast, it works. There's nothing we can do to avoid using it, sadly. The good news is not all of the industry uses it. It's very verbose. I'm not a big fan of it, but if you join maybe a more corporate business, odds are they might know about it, be using it on some projects, or plan to use it in some major projects. So yeah, that's BEM. Now let's show an example of how we could resolve a small style recalculation cost. So basically, to avoid style recalculation problems, just simply avoid deeply nested selectors like this one. So in this case, this would check inside all body.toggled elements, then inside of all of that, any main elements that match, then inside of that, all box elements that match, and then inside of that, all box elements that match once more, and then it does an end child to end for that. Wow, that is a very complex selector. We can reduce that in complexity drastically by just using box container and then adding this immediate child selector. So instead of looking at all children at all levels for box container, it only looks at the first major level. So it reduces the complexity drastically, and then we can keep using this one. So yeah, that's the easy way of decreasing selector complexity. So yeah, and also pro tip, you can measure style recalculation cost as shown here in the DevTools. And the best way to measure it is using the performance panel. Style recalculations appear in purple. So here you can see a very obvious case of us needing to basically tweak our style recalculation cost, because it's way too high. As you can see here, it's ridiculous. So if you're interested in this, here's a link about how we could identify this with the Chrome DevTools, but we won't go into too much detail because that's not the core thing about the slides, and we only have 1 hour, to be honest. I'll try to cover that in the DevTools workshop that's coming up next. Now, Too long didn't read. It's this time is short and sweet. Just reduce the complexity of selectors. Okay, guys, just do your best. I know this isn't easy. It's sometimes hard, but something that helped me out back in the day was stop thinking that classes are bad. I had this concern. I'm sure a lot of you had this as well. Like, should I not be creating as many classes? No, create as many as you want. Seriously, these don't have a performance impact unless you're going seriously overboard, like in the millions. So seriously, don't worry about that. Create as many classes as you want. They're much faster. Okay. Now, layout. Layout's the next section in the pipeline. So what is layout? Layout is basically the phase where the browser figures out the geometric information for elements, their size and location in the page. And basically, the primary elements that contribute the most to layout cost are the number of elements that require layout and the complexity of those layouts. And to show you what I mean, let's look at some layout problems, okay? So let me give you this example. This is the first major layout problem you can have while trying to optimize a page, and it's called forced synchronous layout. Basically, the original order of things is that JavaScript should first run. First JavaScript, then style, then layout, and then JavaScript. And then JavaScript, and then painting, and then composite. The thing is, it is possible for JavaScript to abruptly force layout. And that's never a good thing. Like, you're literally saying, stop everything. I want to force layout to occur. And that's absolutely atrocious. It just breaks the entire pipeline. And basically, you should know that in JavaScript, all the old layout values from the previous frame are always known. But if you do any style changes before you ask for a layout property, you will trigger an FSL. So let me show you what I mean. This is the most simple FSL example. We have a function which adds a class to the box element and then immediately logs the box's height. The thing is, because you just added a class, then the browser has to run the entire style and layout phases for it to know what that box's height is. So you're triggering a forced synchronous layout here. You're executing JavaScript just fine in this line, but then because you need the height, you crash the entire process. You call you force the layout to be called and then go back to the JavaScript. And this all happened without even rendering anything to the browser. And this is one of the most common explanations of lost frames. So be cautious about this. How to fix it? Simple. Stop calling. If you need any properties, any visual properties from the element, do it before you add the class. That way, these properties are always cached as soon as you start running the JavaScript. So you get the properties without triggering layout. And then if you need a class list to be added, no problem. Do it. It will be added as soon as things will happen in their natural order if you do it this way. So long story short, batch all your style reads first and then do any writes. That's your best bet at avoiding forced synchronous layout. Okay, guys? Cool. Now, let's move into layout thrashing. Ooh, this is a scary one. And I think I've been guilty of this, but let's not talk about that. So, layout thrashing. There's a way to make forced synchronous layouts even worse by doing lots of them in quick succession. That's called layout thrashing. And that's like a cardinal sin if you ever do that. So, basically, layout thrashing is, in this example, here you're setting it looks all good and harmless, like, yeah, I'm just changing the style width of one of these paragraphs. But because you're using the box's offset width, this changes every single time you update the style. So basically, every single time you try to set the style, you force a layout to occur to get the offset width. Then when it goes into the next one, it repeats the same process again. It sets the property in CSS, then it forces layout to occur to calculate the box offset width. It does it again and again and again, and it's just layout thrashing in its purest form. So how to identify forced synchronous layouts? Again, performance panel makes this super easy. It looks like this. This is what a forced synchronous layout. And the best thing is, the Chrome devs are amazing. They even give you some hints most of the time as to what could be causing issues. And here we're already getting it. Forced flow is likely a performance bottleneck. So basically, yeah, if you ever have problems, always use the performance tab, because that will probably help you identify what could be causing it. Okay, guys? And also here's a quick example, which we won't take a look at because we are short on time. Now, too long didn't read. Avoid triggering layout whenever possible by not modifying geometric properties. I know this is impossible in many occasions, but if you do, make sure to batch your style changes, your style reads first, and do any writes last, just to avoid for synchronous layouts as much as possible. Okay, guys? Cool. Now, painting is one of, if not the most interesting phase for me, because this is the actual process of filling in the pixels that eventually get basically composited into the user's screens. So this can easily be the longest running of all tasks in the pipeline, and the one that you need to avoid at all costs whenever possible. So basically, as you can see, the downside of paint is that if you change any property apart from transforms, that's going to trigger paint every single time. So, oh, sorry about that, guys. There we go. So basically, if you change any CSS property that isn't transform or opacity, you will trigger paint. And yeah, that's not good news at all. Like, basically, no matter how hard you try, if you change any property that isn't one of these two, it will trigger paint. And if you trigger layout, you will always trigger paint because it comes before the paint phase. So yeah, I think you're probably already thinking what I was thinking when I first saw this. How the heck was I supposed to avoid paint, right? It sounds impossible, right? So yeah, I don't blame you. It sounds impossible. Trust me, it's not. But we'll see soon about that. But first, before we get to the trick section, let's first just quickly review that you can also profile painting. And this part is actually pretty advanced, but you can also use a paint profiler. So if you select any of the painting areas in the performance tab and select the paint profiler section, you can see all the actions the browser takes to draw your entire layout. This is pretty advanced stuff, but it's amazing. So you can this actually helps you figure out what of the properties changed is what's causing the layout, the painting process to be slowed down. So yeah, painting can be problematic, and it is problematic. It's easily the most problematic property for animation. You will always be fighting against doing as little painting as possible, just as JavaScript. So too long didn't read. Pixels are expensive, super expensive, and even more so in low-end devices. So to avoid this as much as possible, try to avoid triggering layouts, because this is something that triggers the paint process, and try to reduce paint triggers by avoiding changing properties that trigger it. We'll learn more about this very soon, but let me give you a short and sweet example. Say you have I don't know, a div container, and that div has, like, I don't know, 50, 60 HTML elements inside it. Say you moved that parent div 5 pixels to the right, that would trigger a layout and paint change on all the elements inside of it, and that's never a good thing. This is why moving complex HTML structures or animating them is such a challenge, because you're triggering paint and layout on so many elements at once. So that's certainly something you want to avoid. Okay, guys? So compositing. Here's where it's going to get interesting. So compositing might not make a lot of sense. Like, even the name sounds weird. Like, what the heck is compositing? And compositing is where the painted parts of the page are put together on the screen. Or simply put, basically the browser paints all the parts that make up a page in memory. And then compositing basically takes all these pre-painted parts in memory and ensembles them together. It basically puts everything together as layers to show the actual bigger picture. Now, there are two key factors that can affect compositing page performance. Do keep in mind that compositing is usually quite light. Like, you have to try really hard to get compositing to slow down. And the biggest factors that can slow it down is when you have too many layers that need to be managed, or when the properties that the properties that you use for animations, these can sometimes affect compositing. So the there's an easy way of actually relying on compositing to make the painting process easier. So there are actually ways that you can promote an element to its own layer. And this is what allows it to have even faster performance when doing any kind of layout or paint changes. So let me give you an example. Say we have, I don't know, let's say we have multiple, let's say we make a site where we have blog posts. Each blog post is like a card, and you want that when the user clicks it, the card animates. So to improve the card animation performance, you can promote the card to its own layer so it animates with higher performance. And this also means, by the way, this is something I should have included in the presentation. So pay close attention to this I'm about to say. Compositing almost always benefits from GPU acceleration. So what do I mean by this? Any mobile or even desktop modern device, even low-end ones, have a processor, which is the CPU, and a graphics card, which is the GPU. The graphics card is something that is rarely used by websites, except by the compositing phase. So basically, by promoting things to their own layers, you are benefiting from advanced graphics card acceleration, which allows for even better performance. This is why compositing is such a cool thing. So if you want this to happen to some of the maybe complex elements which you will be animating, feel free to use the will change CSS property. This is currently supported by Chrome and Firefox. And basically, if you set any element to a will change, let's say will change left, basically that what you're telling Chrome and Firefox is, hey, this will probably animate, so please promote it to its own layer if I make any changes. So it's super useful. And then the old way, this is the old way we did things. You could also set the CSS property of transform to translate Z. This was a super hacky way, but it promoted the element to its own layer on browsers that don't support the will change, like Safari or Internet Explorer. So by using this hack, you can actually force elements to have their own layer to benefit from GPU acceleration on older, or well, not older. Yeah, this still has to be done on Safari and Internet Explorer. These two are atrocious browsers in their own right. They're just hampering innovation, but whatever. That's a topic for another session. So yeah, analyzing the composite phase is actually quite easy in the DevTools as well. Surprise, surprise. So to do that, you can actually bring up the layers view in the performance tab by just clicking on a layer after you brought up the painting setting in the settings subpanel, and then switching to layers subtab, as you can see right here, allows you to see every single layer on the page that is being rendered and composited to ensemble the larger big picture. Okay, so yeah, something to keep in mind. Cool. Now, TLDR, use only transform and opacity changes for animations. I know this will be a challenge, but bear with me. And last but not least, use will change and translate C to promote animating elements. I should have added complex animating elements. You definitely don't want to add this to all elements that you're animating, especially if they're relatively simple ones. I would only do this for more complex elements, like that card example I told you about, because that card is going to have things like the title, the link, the button, the paragraph, some images, stuff like that. So that's quite a complex element that needs to be animated. That would be a good candidate for will change. Okay, cool. Now, before we wrap up, what triggers what? So if you're ever stuck, like me, wondering what CSS properties trigger what rendering process, be it layout, paint, or compositing, this is an amazing resource. This is something you have to bookmark. It's called CSS Triggers. And basically, it gives you, as you can see, every single CSS property available to you, and it tells you what it triggers. So it could be layout, paint, or composite, and it tells you what that would be like on each browser. So these are browser and rendering engines. For the people unfamiliar, as far as I know, Blink is used by Safari, Gecko is used by Firefox, WebKit is used by Chrome, and Edge HTML is used by Microsoft newest browser, Edge or Explorer or whatever. So this is a super handy chart to basically let's say you want to animate the left property. So let's say we want to animate the left property. There's left. And surprise, surprise, left alters the geometry of the element. That means it may affect the entire position or size of other elements on the page, which causes an entire chain of layout operations, painting operations, and then composite operations. So super handy resource. Ever want to animate a property? Check this page first, so you can analyze the cost it will have on the browser rendering pipeline. Okay, guys? Cool. Now, let's move on. So, we're pretty close to the end. But what we were all waiting for. CSS Animations to the rescue. So, for those unaware, you can actually write animations with pure CSS. So, by using our newly found superpowers of understanding how the browser rendering pipeline works, we can actually write high-performance CSS animations that rely only on the composite face properties. So basically, if you were to make a CSS animation that only animated the composite face properties like transform and opacity, as you can see, you skip the entire pipeline. Holy crap, that's huge. You're jumping all of it. You have an entire 16 milliseconds for a smooth animation. So how would this work? And let me show you. So this is going to be an example of the animation we just saw, a square moving from left to right, but it's going to be done with a transition. So the way transitions work is you basically, to animate a property, you do use the transition property. So all you're doing here is saying, hey, can you please, whenever I change this property I'm telling you right here, please allow it to animate over a time frame of 1 second. And then to get it to update, all you have to do is just change it, literally. So to do that, we're just using the pseudo class. For those unaware, this is a CSS selector that only activates when you hover on top of this element. So every time we hover on the box, it's going to change the transform property. So remember how we said we can only use opacity and transform. Opacity is kind of self-explanatory, but transform is super powerful. You'll be surprised to know how many things you can do with just transform. So here, we're doing translate X to move it 100% to the right on the X-axis. So to show you what that would look like, let's quickly see this example in action. So here we have the same box, except this time there is no JavaScript whatsoever. The only things active right now is the transition property, which you can see right here, and the transform property, which as soon as I hover on top of it, it animates. Pretty cool, right? I'm not clicking. Seriously, I'm not. I'm just hovering on top of it. Like every time I hover, it animates. It's pretty cool stuff. So that's an animation using the transition property. This is something you're going to be exploiting a lot. I'm sure of it. So because yeah, like buttons, hover effects, stuff like that, go nuts. And seriously, I don't blame you. So if you're curious at how to better use transition or transform, Google is your best friend. So if you Google MDN transition, so MDN is a Mozilla Developer Framework. I love their documentation. It's just fantastic. They give superb explanations to most topics. So here you can see how the transition property works, what properties you can give it, some examples of how you could use it, and all the ways you can customize it. So it's pretty amazing, to be honest. So check out the transition property, and even more importantly, check out the transform, so you know all the types of animation you can do just using transform. For example, here we can see that these are all the main types of transformation. So there's the matrix transform, which literally, did you see what that did? Like, holy crap, that's amazing. So that's the matrix transform. Then we have the translate transform, which moves around. So you can move it around by a fixed amount, like pixels, or a percentage. This is when you have two values, it's usually the X and Y axis. So we moved it 120 pixels to the right and 50 downwards. Then you have the scale property, which can scale it on the X and Y axis. So that increased the x-axis by 2, by a factor of 2, and decreased the y-axis by a factor of 0.5. Then we have rotation, which is something like this. So you can rotate it. This should also work by degrees, by the way. And then you have skewing, which skews it on the... I have no idea how to name skew axis, but basically you have the skew axis to skew it. And finally, we have the ability to combine them, which is something you're probably going to want to do for more complex animations. So you can actually use more than one type of transform at once. So as you can see, here are a ton of more examples of how you can use transforms and all the values they can take. So yeah, as you can see, I think you're going to have quite a lot of fun just going over this and just enjoying all the types of animations you can do. All right, now you think we'd be almost over, but we're actually not. We have one more thing we want to go over super quickly, and that's keyframes. So you saw transitions. So transitions were just a way of animating things reactively. So say you don't want to animate something reactively, you just want something to be constantly animated, and that's where the keyframes come into play. So keyframes allow you to define basically like a timeline of how an element is going to animate, and then you can assign that animation to an element. So in this example, I'm going to assign to my box an animation called slide animation, which I defined in my keyframes right below. Then I set other parameters, which are very important, like the animation duration. Then these two are optional, but I really like these two. So I like to use an iteration count to force the animation to run infinitely. And then in animation direction, I set it to alternate. So that way it will run first from 0 to 100%, and then from 100% to 0 back. So it's going to be like going back and forth. This is great for looping animations. So here's what the animation looks like. You write the keyframe animation using the add keyframe syntax, and then using the percentage, you define how many like how can I put this? Breakpoints wouldn't be the right word. Maybe milestones? No, that's not good. Let's just call them timeline pointy things that mean something. Okay. So basically, you define one at 0%. Then another one in 100%, and it's going to be animating from being translate 0 to translate x 100. So it's going to be moving from its current position on the x-axis to one whole unit of itself on the x-axis. And to show you what that would look like, let's see this cool live example right here. And come on. There we go. So that's, oh boy, don't tell me I have the wrong link. Yeah, I have the wrong link. Yep, totally think I forgot to update it. So let's apply the old one. So this technically should still be the code that animated it. There we go. Not perfect, but did the trick. So as you can see, our box is now animating constantly. So basically, this is the actual animation, the slide animation. It moves it from the x-axis from being 0 of itself to 100% of itself. And because it measures 200 pixels width, it's going to be moving to the right on the x-axis 200 pixels, which is 100% of its width. And then to get it to repeat infinitely, we set the animation iteration count to infinite. We set the animation direction to alternate. So it goes from left to right and then from right to left. And then last but not least, the most important properties, how long you want the animation to last and what animation you wish to use. Okay? So yeah, excuse me so much about that. This is something I definitely made a mistake, so I'm going to update that super quick before I forget. So let's call this keyframe animation, because yeah, I tend to keeping this material up to date is crazy, you know. I really like giving out workshops, but it's really hard keeping all of the material up to date. Here we go. That's up to date. Please don't tell me I overread the previous one. Oh my god, I did. Okay, I'll deal with that later. Okay, let's go to the next one because we're super close to the finish line. Inspecting CSS animations is also something you can do for those unaware. There's a hidden animation panel which you can access on the DevTools, and it allows you to record, identify, and fix animation-related issues. That's actually fantastic. So here we can see the animation panel, what it looks like in the official Chrome developer docs, an overview of what it's used for, how to enable it, and how you would identify animations. So this is what animations would look like. And just by monitoring this panel, you can actually see a live demo. So as you can see here, here's a live demo. They're using a page. And notice how the animations are just adding up. As he's showing you animations, they just keep adding, and he can actually test them all one by one. So that's pretty amazing stuff. And you can do all kinds of crazy things, like slowing down the rate of the animation, and all kinds of things just to make it easier for you to figure out what's causing the animations to not be orchestrated correctly. Okay, so TLDR for our last section. Always try to create animations that trigger only the composite phase for lightning fast performance. That is opacity and transform. Don't forget it. And CSS animations are, of course, the perfect option for composite animations because they allow you to skip the entire pipeline, even JavaScript. And that is why they're so popular nowadays. And yeah, that's about it. Thank you so much, everybody, for attending. I hope you enjoyed the session. We have about 10 minutes, which we can use for questions, or I have one bonus round if you guys want to hear it, which is basically just one of my favorite all-time links that helped me become better at animating things. Do you guys want to take a look at it, or should we just use the last 10 minutes with questions?